Today we are going to be reviewing the warm-ups for SOL 8.8 and 8.9. SOL 8.8 covers the top, side, and front view of three-dimensional figures made up of either blocks or smooth surfaces or three-dimensional figures such as cones or rectangular prisms. SOL 8.9 covers the Pythagorean Theorem. Problem number 1 says a three-dimensional figure was constructed using identical cubes. The top, front, and left side views of the figure are shown. Which could be the figure? So looking at this top view, we have 1, 2, 3, 4 on one side, and 1, 2, 3, 4 on the opposite side. So whatever top view that for our figure should have a 4x4 L shape. So A has 1, 2, 3, 4, and 1, 2, 3, 4. So that's a candidate. B has 1, 2, 3, 4, and 1, 2, 3, 4. So that's a candidate. C has 1, 2, 3, 4, and 1, 2, 3, 4. A candidate. And D has 1, 2, 3, 4, and 1, 2, 3, 4. So all four of these based on the top view could be the answer. It's important to note that in an example like C, just because all of the top view aren't on the same height, because we're looking at it from the top, they still count because we can see them from the top. So let's look at the bottom view, which is this yellow color. And it looks like we should have a row of 2, or a column of 2, a column of 1, column of 2, column of 1. A has 2, 1, 3, 1, so we can actually count out that whole problem. B has 2, 1, 2, 1, so it's a contender. C has 2, 1, 2, 1, so it is a contender. And D has 2, 1, 1, 1, so it is not a contender. I do want to note that this face would be the same as this face, because if you're looking at it from the side, you actually wouldn't be able to see that at all. So now we're looking at the left side view, which is this red color, and it looks like we should have 1, 1, 1, 2. So looking at B, we have 1, 1, 1, 2. So that should be the correct answer. C has 1, 1, 2, 2. Before I move on, I want to mention that this face right here would be the same as this face here, because if we're looking at it from the left side, you actually wouldn't be able to see that at all. It would be blocked by this one. Moving on to number 2, which of these figures have the same top view? So if I'm looking down at A, I'm going to see this face, and this face. So I'm just going to see 3 squares in a row. If I'm looking down at figure B, I'm going to see this, and these. So it's going to look kind of like that. Figure C, from looking down from the top, I'm going to see that, and that. So it's going to be a row of 3. And if I'm looking down on figure D, I'm going to see here, 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 and here. So a row of 4. So that means that figure A and figure C have the same top view. Number 3, given a triangle with lengths of 6 centimeters, 10 centimeters, and 8 centimeters, is the triangle a right triangle? So of course, a right triangle is any triangle that contains a right angle, and it has our 2 legs, A and B, and our hypotenuse, C. The hypotenuse is always the longest side of the right triangle, so we're going to use the 10 for C. And for our 2 legs, A and B, it really doesn't matter which is which. So I'm just going to say that A is equal to 6 and B is equal to 4. And the Pythagorean theorem is what we use with right triangles to either find a missing side or to determine if the 3 sides make up a right triangle. So for A, we're going to substitute in 6. For B, we're going to substitute in I am so sorry, I made a mistake. This should be an 8. For B, I'm going to substitute 8. And for C, I'm going to substitute 10. Now we square our numbers. 6 squared is 36. 8 squared is 64. And 10 squared is 100. 36 plus 64 is 100. And since we end up with a true statement, 100 equals 100, yes, this is a right triangle because those 3 sides fit the Pythagorean theorem. If you have any questions, feel free to email me or put them in the comments below.